TVS is the company that's provided the independent television service for the south and southeast of England since the 1st of January 1982. What you're about to see is just a sample of our output. Our main science program is the real world. Subjects covered have ranged from holophonics to robotics, from food to sleep, from aging to herpes. But perhaps the most notable was the edition which allowed all of Britain to experience colour television with an extra dimension. These pictures were the first ever to be generated in a British television studio using a new American 3D colour system. The programme explained how the various methods of producing 3D images work and how the entertainment industry is spurring development on.
Don't give me the whole spiel, just tell me if you can do it.
It also reported on pioneering work being done at London University.
Professor Boyd has been using the 3D electron microscope to examine a wide range of specimens. This is an Indian millipede which continues to generate segments of its body throughout its adult life. Without the extra dimension, these detailed images would be almost indecipherable. And what happens inside this bone is a major area of interest to scientists. You may imagine that your bones are with you throughout your life, but in fact, for all of us, practically our entire skeleton will be eaten away and replaced by completely new tissue within a 15-year period. The process involved in this remodeling and what happens in disease can be revealed in fine detail under a 3D scanning electron microscope. And the scientific applications of 3D don't end here. 3D cameras are used regularly in hostile environments, investigating undersea wrecks or in the heart of nuclear reactors.
Another program looked at genetics, at developments in the field, and at the moral and ethical problems which arise out of those developments.
At a laboratory in the University of California, San Francisco, they're working with the fluid which surrounds the baby in the womb, the amniotic fluid. Because it contains cells from the fetus, the fluid has already provided doctors with a wide range of information. Now scientists are able to isolate DNA from those cells. By using new genetic techniques, that DNA can be analysed. And this means that Dr. Yuetwai Khan can now tell prospective parents at an early stage what they otherwise couldn't have known until the birth of their baby. In this particular anonymous family, mother is number 1. She has a sickle cell gene at the top and a healthy gene, so she's a carrier. So is number 2, that's the father. Number 3 is a child with normal genes, so it's fine. But the fetus, number 4, only has a sickle cell gene. Doctors can be absolutely sure that this baby would suffer from sickle cell.
The hope of people working in this field is that someday we can use similar recombinant DNA techniques for gene therapy. By that, I mean to replace a defective gene with a normal gene. That is the dream that many scientists have, that is to correct a genetic defect at the molecular level, at the DNA level. If that's successful, I think that will be a great achievement.
At the University of California, Los Angeles, Professor Michael Kabak is one of the leading voices in the field of genetics.
Well, the idea of breeding perfect people is really nonsense. When you realize that every one of us is imperfect, we all carry between 5 and 8 lethal genes in what is called a non-expressed form. None of us are structurally perfect or functionally perfect. So I don't think that such a thing as the perfect race is really going to evolve from this. The concern, however, Sue, that your question really raises is that as our technology gets better to pick up lesser and lesser defects, for instance, in fetal life, where does our intolerance for imperfection end?
And the real world also reported on the progress that's being made on helping people who suffer from physical disability.
These creatures haven't changed much in 100 million years. They're called axolotls. They're a kind of newt. and scientists at the Medical Research Council are looking at them because they can do what man can't: regrow lost limbs. This X-ray shows how the tips of David Leckenby's fingers were lost in an industrial accident. David, after you lost the fingers, what happened to them?
They started to grow back virtually straight away. Within 6 to 8 weeks, they were grown again and nails on them complete.
Well, and do you have complete sense in them?
Yeah, perfect touch, can feel everything, you know, exactly.
Our industry unit specialises in getting right down to the bottom line.
This is a 1/10 scale model of the S90 which Thornycroft Giles will be testing for the next few months in Bembridge Harbour. At the same time, the Royal Navy is evaluating the mass of tests done already. So far, things have gone well for the team. The S90 seems to be behaving well and to be capable of doing what is required of it. It seems that it will meet the Navy's seakeeping requirements and that it will carry an immense load without needing excessive power to push it through the water. And its cost has been worked out. A basic hull with propulsion machinery should cost half as much as a conventional hull. And this is what it'll look like if and when it ever gets built. We filmed it with a high-speed camera. Run the film at normal speed and it shows what a full-sized S90 will look like at sea. Over the last few months, the chances of it becoming a real ship instead of a model have grown, as an increasing number of people have come to take the project more seriously. David Giles.
A number of other companies, major companies, interested in defence equipment particularly, have joined forces with us. And I can only conclude that these companies are not stupid, and they realise that the time has come for this country to get back into the business of building warships and exporting them and making money. And if they're going to do it, they've got to have the right designs, and the designs have got to be cheap and they've got to carry a big load. And they realize that the less money that can be spent on ships and hulls, then the more money will be available for the equipment, which really matters.
And that matters to the politicians too.
It's horrific that for many years now no foreign country has bought a British-made warship. That means that British jobs are at stake. That means that the British shipyards, which have all these tremendous skills at building warships, are not being fully utilized, and the men on the dole who ought to be working today. What I'm really saying is that I'd like to see some of those yards building warships ordered by the British Navy, made to private designs. Let's try it out. Let's see how we get on. It's never too late to start again. It's never too late to sharpen people up. It's never too late to introduce new ideas. If I were Winston Churchill, the Prime Minister, I'd write on half a sheet of paper, "Pray bring me an alternative design," and put it into operation, and let's take a look at it. Let's see what's best.
I would like to think that you'll see one of these things in the water within 3 years or so. But I may be over-optimistic. It may be 30 years, but it will happen. It's bound to happen. Sometime somebody is going to have to find a way of producing the ships to do the same job for less money.
Just some of the programmes produced in the south and southeast of England by TVS.